Yeah. I'd be anybody in this class.
So you may choose those two also to do. Those will can turn out to be very beautiful forms. And then the red one to the right is the tetrastar. And some of you might choose to do the tetrastar. Now, I need you
That's not cubo cube.
Look at it. That's what we're doing. Can you help us improve that? Yeah, but we didn't do that.
This video contains 3 sections: a cube project, a polyhedron unit, and an architecture segment.
What the is your piece of problem, you stupid?
Well, learning hands-on, making, constructing all these things, because it's better than learning from the book, because for all of elementary school, I've been learning from the book, and now that I've started junior high school, and now I'm graduating, I understand actually more of the things that were taught to us.
I agree. I think that hands-on curriculum helps you understand better instead of just seeing it in a book.
Hands-on curriculum, I think it's a good idea because, well, it's fun and also, it makes it's easier to understand, what geometry is all about and.
About hands-on curriculum is that I learn more about geometrical shapes and
Well, the thing I liked the best was, I think, stellating the shapes.
To construct your own shape, and you could also work with other people and they could help you make it and stuff.
Well, it helps a lot to discuss what you're doing with your peers, because if you're having trouble doing something, you could just ask them and they'll be like, "Oh, sure, I'll help you."
Students continue drawing three-dimensional cubes, connecting these representations in various arrangements on hex paper. This graph paper facilitates the learning of three-dimensional drawing. Learning to use coded plans together with Linko cubes, students make the connection with 3 dimensions. Students enhance their ability in spatial relations as well as spatial orientation. This study includes planar perspectives, since this gives many students the advantage of seeing multiple cube arrangements, such as pentacubes. Now students are prepared to undertake the project of assembling a 4x4x4 cube using various arrangements of pentacubes, which have already been explored two-dimensionally. Linko cubes serve nicely as the manipulative to allow students to jointly discover the correct combination and arrangement. After this is figured out, students begin the project of deciphering how each of these pentacubes will be drawn as a coded net. This net will be cut out and folded into the various pentacubes, resulting in the discovery of which pentacubes fit in a 4x4x4 cube. This becomes a massive undertaking, and therefore students are urged to work collaboratively in groups of 3 or 4. The teacher serves as a facilitator, as students begin to rely on each other as sources for understanding.
8, 7, 8, 9, 10, 11.
15. Let's see which ones we did not have it. Form something.
This one? See if we have anything twice.
This one's L-shape? L-shape? Yeah, this? No, I don't think we have that. No. So that's how many? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we should have 18. No,
I know another shape.
18, because we have 90 cubes. So we need a shape with 4 cubes.
I know.
What? How did you do that?
Pentacubes. Yeah, because what you'd have to imagine is that when they were on flat paper and you were cutting them out, you were cutting out all of the faces put together. Right. So you'd have to visualize all of the faces being folded over, and then so it's on one flat plane, and then being able to fold it back together again to make the
I think that was the hard part. I always left that like aside.
Right, and making sure not to leave out one cube, because...
Yeah, because when I was doing it, the first shape I did, I must have done it 3 or 4 times before I actually got all the faces in.
Yeah,
I was leaving out 1 or 2.
We did.
And I think, like, it helps yourself with, like, control, because in a lot of this stuff, you have to be patient, and because you might mess up 5 times before you get it right, and you have to be able to work with the tools that we did, like the X-Acto knives, and being able to cut and measure and all of this stuff, so that'll help us with just...
That was good, though.
Yeah, that would help us
working with the tools.
actual construction with the tool. Because it was better for us to work with it than for a teacher to cut it for us. And then
the X-Acto as opposed to a scissors.
Yeah, we actually, it's very precise, and I'm planning on being a doctor, and I even think that the precision in this will help me. Project was to take 5 cubes, which is together makes a pentacube, and to take these pentacubes and one block of 4 cubes, and to build it together so you get a 4x4x4 that looks like this, which is 64 cubes.
It was supposed to like help us visualize 3 dimensions, because also we're working on these like, 3-dimensional polyhedron things, and so it helped us like
Get comfortable working in 3 dimensions.
Yeah, comfortable working in 3 dimensions, and also we have to construct these, like by measuring different parts of it, and we had to construct these 4x4x4s.
It's using the same principle.
Yeah.
Well, we started off with drawings on graph paper of the cubes, so that helped us go to the next step, which was to actually use Linko cubes and build it. But I felt that when we used the stuff on the graph paper, I could understand it more because I was more comfortable with 3-dimensional things.
Yeah, but I felt using the Linko cubes was helpful because you could help see what you're trying to draw out.
But it wasn't as hard to visualize as it was on the paper.
I think the paper helped me. It helped when we did the paper first, as opposed to we didn't go straight into the 3 dimensions. I thought that helped me visualize what it was going to be in 3 dimensions. I think it would have been too much to go to the 3 dimensions first.
Well, when Joyce and I did our 4x4x4 together, And when we were building it, we thought that the easiest way would be to just start with the bottom layer and build up.
You need to speak a little louder, yeah.
Okay.
Emily's fine, but I think the other three of you need to.
No, we'll let this happen.
Okay. When Joyce and I decided to do, when we had to do the 4x4x4, we thought it would be easier to start with the bottom layer that was all put together, and then we built up from that. So we didn't actually plan out which pieces we were going to use, so some of them were repeated, like that one we used twice.
Yeah, we more like experimented and picked pieces at random and just try to guess what piece would fit.
It was like trial and error.
Yeah, exactly.
What didn't work, you tried another way and undo that layer.
And if we ended up with the top and then like pieces were sticking out, then what we would do is we would undo a couple of pieces and then try to build it back together with
just
what
that
we
one
had.
layer.
Yeah.
Yeah.
So.
So what else?
Question are we up to?
The only basic problem that I encountered in the making was connecting it. Like it was very hard using the tabs, building the three-dimensional cubes, pentacubes.
Yeah, because what you'd have to imagine is that when they were on flat paper and you were cutting them out, you were cutting out all of the faces put together.
Right.
So you'd have to visualize all of the faces being folded over, and then so it's on one flat plane, and then being able to fold it back together again to make the
Yeah, I think that was
three-dimensional
the hard
piece.
part. I always left out like a side.
Right, and making sure not to leave out one cube because
Yeah, because when I was doing it, the first shape I did, I must have done it 3 or 4 times before I actually got all the faces in.
Yeah, I
I
always
was
like
leaving out 1 or 2.
Why do you think that's so hard to do?
Because a lot of pieces overlap, and it's like hard to like visualize them.
And we also forget about little pieces in between. Like we remember the big faces, but once it has only one little side, then you kind of leave it out because you don't imagine where it's folding from. And sometimes the pieces can be, 2 of the same faces can be in one spot on the paper, so you'd have to find another place to put it so it would fold over into the right place. Yeah.
It was hard to put it from 2 dimensions into 3 dimensions. It's hard to like convert it over.
It took me a while to comprehend.
So I thought it was helpful when we drew it out first because that even helped me.
and all of the different things in the booklets. It wasn't only drawing them out on graph paper.
Yeah, it was the coded plans.
Right, working with the coded plans and
so we can see the views.
Different views.
The different views. That helped a lot too.
I also think that the construction of these is going to help us with our polyhedrons.
Yeah, this is our final step.
Because we know how to work with the flat planes turning into three-dimensional.
And it's basically the same principle, cutting out one sheet or two and folding it to become
three-dimensional.
I think it'll be easier to do the polyhedrons now that we've already done our 4x4x4.
Yeah, because like you can see in this, the polyhedron's inside of this cube, and so you could understand the placement, and that's what you really get from all of this stuff. You can visualize three-dimensional things in the natural world and stuff.
Yeah, I thought this helped me visualize in 3 dimensions, like in my head also, because since I couldn't always be doing it on paper, I would have to do it in my head, and I thought it helped me visualize the 3-dimensional cubes, and I think it'll help me also with the polyhedrons.
Yeah.
Everything seems to help me with the polyhedrons.
Yeah, and since all of these cubes put together makes a 4x4x4, then it was